Okay, I'm going to talk about solving questions 2, 3, and 4. Now, question 2 asks you to state or to tell two places where pulse can be measured or taken. Pulse is the heart beat. Where can you feel it? At the same time, we can measure the heart rate by measuring pulses per minute or heartbeats per minute. So here are the places where pulse can be measured: in the neck, armpit, thumb, palm, wrist, groin. This is a groin, the one which is here under your tummy. This is a groin. Do you see it? Here it is. You can feel pulse. Okay, now the question says, suggest one feature of these sites. Very important to know why we can feel the pulse of these sites. We can feel the pulse because the blood passes through arteries that carry high blood pressure against bone. We press it against her something which is bone or tendon, and these arteries are near the surface of the skin. They are not deep, so we can feel the blood passing through them, and then we can feel the pulse. So these are the main criteria for these areas. Okay, so here okay, B, describe how you could measure the pulse and use this to estimate the heart rate. As we said, we apply a pressure, or we press on the area that has high blood pressure. One of these areas, either underarm or neck, wrist, whatever it is, as shown in the figure. Here we press. So the first point goes for pressing or apply pressure, and the second point for counting the beats per minute. We should take it over minute. It's very important to estimate it over 1 minute, over 60 seconds, to see how many beats we can have over 1 minute. So let's go to the next question here. Here this figure shows a section through two blood vessels. By the way, the figure here is under photomicrograph, under microscope, so you should be familiar for how vein and artery look under microscope. Vein, the one which is on the left, and artery, the one which is on the right. It's very clear which from the thickening of the wall and thickening of the muscle, and from the lumen that each one has. Okay, let's go to see I and to see what it asks for. Yes, here it asks for magnification. You should take the length from x to y, and here is the equation. After you take the length, you measure it, then you show your work. So here, in order to calculate the diameter shown by xy in millimeter, you should take the measure length of the xy on the image. Let's go back to the image. It is set under microscope. So always the specimens under microscope, they are magnified. Look at the magnification here. It is 125 times the real size. So the magnification here, it is shown. Do you see the cursor? So it is 125 greater than what? Than the real size of it. So once we measure the distance from x to y, it is the magnified length. According to the law of magnification, MA equals magnified over actual. Magnified, which is 1 in xy, and actual, we're gonna find it, which is unknown. So here we put magnification, which is 125, equals the one that you have in the figure, XY, okay, over actual. Then you're gonna find it. Here you have two ones which are known to you. The magnified one, you measure it, and the magnification, which is 125, you can find out the actual diameter or the real size of it. So here, let's go to the next question. The length of XY may not be the most accurate measurement of the diameter of the blood vessel in figure 2.2. Suggest how you could determine a more accurate measurement of the diameter. We can have more than reading across different position. We take different diameters, not only this one that was shown by the figure. I can take more than one diameter across different positions and calculate the average. The average, what is meant by the average? How can we find the average or the mean? Average or the mean, both of them the same. How can we measure them? We add all the readings that we have together. We should find the summation of them divided by their numbers. If we have 3 readings, then after adding them together, we divide them by 3. If we have 4 readings, we add them together and we divide them by 4. So this is the average or the mean. You have to know it because it is included in every question. The vein and artery in figure 2.2 have features that are different. Complete the table 2.1 to name 3 features that are different and describe the differences that you can observe. So here it should be observed from the figure. Let's go back to the figure and see what is being observed here or what is shown. First of all, if we look at, you can take the feature lumen. You can say that lumen of vein is wide, while in artery it is small or narrow. Let's talk about the wall. The wall of the artery is thick. Here is the wall of the artery. Do you see the cursor? The cursor, the one which is lighter in color, the above one. Here it is. So in artery it is thick, while notice here it is very, very thin compared to artery. So the wall thick in artery, while in vein it is thin. For the muscle, the elastic muscle, do you see the one which is bolder here? The one which is bolder than this. Here the cursor where this, the whole layer. This, it is the thick elastic muscle. Here it is very thin compared to artery. You can talk about the shape. What you have seen, the shape. So the other feature that you can compare is the shape. The vein is round while the artery is oval. Look at the shape. So this is an observable feature that you can feel it here. Okay, so let's go and talk about this investigation. It's very important to know this investigation. When running, the heart increases. After running, the heart rate